Have you ever taken a trip to the mountains? Did you notice that at the top of the mountain it's actually cooler than at the base of the mountain? As a matter of fact, when you travel above the Earth's surface, the temperature decreases for each mile that you're above the Earth's surface. We can take a look at a graph of this and the equation y is equal to negative 11x plus 68. It actually models this particular real-world situation. Notice the horizontal axis is the height in miles, and the vertical axis is the temperature in degrees Fahrenheit. Notice that as you increase the height above the surface of the Earth, the temperature decreases. When a real-world situation is modeled by a graph like this, we can sometimes talk about the slope of the linear function, and it may be interpreted as a rate of change. Slope of a non-vertical line is actually the ratio of the rise, that is the vertical change, to the run, that is the horizontal change. So the rate of change in this particular situation is the change in temperature with respect to the change in height. That is degrees per mile. We're going to take 2 points, 157 and 246, and see if we can figure out exactly what the rate of change is. So we begin, the rate of change again is equal to the change in temperature to the change in height. For this particular problem, it's going to be 46 minus 57 with respect to 2 minus 1. When we simplify this, we see that we get negative 11 to 1. And so, negative 11 degrees per mile is the rate of change. Let's take a look at the graph and see how this is interpreted in an actual graph. Notice that as the height increases, the slope of the line, the rate of change, actually decreases 11 degrees. Let's do another point and see what we get this time. Suppose we use the point 157 and 424. Again, remember, the rate of change is equal to the change in temperature over the change in height, that ratio. So here we go. 24 minus 57 over 4 minus 1. Here we get negative 33 over 3, which is again negative 11 degrees per mile. You know what? This is a very important property of a linear function. No matter which 2 points you choose, the rate of change or the slope is always going to be the same. Next time you go to the mountains, I want you to think about what is the temperature on top of the mountain as compared to the temperature at the base of the mountain. Have a good time.